And we're back. So let's look at what we have to do today. Last time we implemented this value array and the value stack pointer and the few operations that we determined would be necessary to interact with it from the VM interpreter. And we're actually going to do 3 assignments today. The first one of which is very simple. We are going to basically implement this instruction, not a generic add, but just the add instruction that takes these operands. And using the value stack array, using the value stack. And before that, we have to push the command line arguments onto the stack. So then we'll see whether this stuff actually works and whether we do that correctly. So let's go back to the VM. In the VM, we how about the first thing we do is we make a function that's used by the main function that takes a bunch of let's look at our main function actually, because we already have the parser for the numbers from the command line, right? In eval program main here. We allocate the arguments. We allocate an array for the command line arguments. So we're going to use the same code to do that for our VM main function. Actually, we might want to call this VM test main. VM test main, but then we're not going to use this one. We're going to use VM main, which takes, we're also going to use a context, because then we have a pool in the context. And we can pass the context and argc -2, argv +2. And in our VM main, well, actually, didn't we say return? Yeah, int. Actually, this is our argument list. And what do we call this? We're going to call it parse commit line args, namely context and oh, this is interesting. This assumes that we know how many args there are. Well, whatever. We pass the argc. This is the argc here. Right. Oh, we do check that they're the same. Okay. Argc and argv. So this is that function. Static 64t parse line args. Well, I shouldn't call it. Whatever. And then, wait, what? Parse commit line.
You just it's in the buffer. You cut it and then you took the arguments. You also cut that.
return args. So argc, this is it, right?
Yeah.
argv. Okay, so now I can int 64t args equals parse command line args context argc argv, and now I'm going to make a function vm push args. And this is just for the benefit of the main function. The VM itself, the VM interpreter itself will never use this function because it's composed of a bunch of primitives, essentially. That so there's no VM instruction that does exactly this, right? If you wanted to do exactly this, you would have to write a bunch of VM instructions. But I'm gonna parse it argc and argv, except that, of course, I need a VM as well. Here now we have a VM. Now in my VM, I can implement this VM push args, which takes a VM and it takes an int argc and it takes an int 64t args. Okay, how do we implement this?
So this is just called from the main function, nothing else.
Yes, so this is the part that what we need to do is we need to get the VM into the state where the first argument is in absolute slot 0, the second argument is in absolute slot 1, the third argument is in absolute slot 2, and the value stack pointer points to like directly above that. And we are assuming that the VM here has just been initted, right? So we don't need to. We can assume that the VM is it's an initialized state.
Okay. So we just loop through the numbers and copy them into there into the VM.
Okay. So what do we do here?
VM dot or arrow. Wait. What do we use? The value array?
No, we have all of these nice functions that do stuff for us. Why did we write those? Okay, so first of all, there is no VM push. There is VS push.
I see VS, sorry, VS.
But VS only modifies the stack pointer.
I don't see the.
So VS store?
Store. No, the VS store, yeah.
Okay, so what's the what's the slot that we store it
to? Slot number I, because the stack pointer is right now 0, right?
Yes, correct.
Then argvi. Okay.
And then
the parameters
we do VS push. Args.
Yeah, third parameter is args, not argv.
Oh, sorry. Right? Does this make sense?
Yeah. Yeah.
Okay. So this is how we push the arguments. Compiler. Did I put the VM stuff in the compiler? Yes, I did. VM push args. So, and now I'm going to write this stupid little function VM assignment 2. So all we need to do is what this add instruction is supposed to do. How do we do that?
So where do we get the arguments from the instruction from? Oh, so we're just
This
reading
is the instruction. This is the
Oh,
instruction.
right. Okay. So we're just getting this the values from slot like -2 and -3
Yeah.
relative to the pointer, and then just putting them to the stack pointer in that case.
Well, we also need to add them.
Right. Did I forget that?
VS store,
Okay.
like VS pop or get. I don't know what is
The VS load.
VS load.
Well, we're storing in slot 0, right?
Yeah. VS load. VM. And you have to do -3 and then
Plus.
VS load.
Right? That's it.
Yeah.
So obviously this function is not going to live very long. Now we did that with the VM. And then what are we supposed to do? Code that checks that the array contains the correct values. Well, so what we should do is, so let's just check that the result is correct, right? So we're going to return VS load VM0 in 64T result. And now the result is supposed to be, we had this print thing pre E64 result. And it is supposed to be what?
So
V1 plus RV2.
Yeah, I'm too lazy to do that. So I'm actually going to say plus equals, because I don't want to. Well, no, I do have the args. Of course, I can totally do it. But anyway, so it's args of.
RV? 1?
No, it's args.
Wait, where's args?
the 64 bit.
Oh, okay.
Numbers.
Yeah. So then 0 and 1.
Well, no, it's not that simple. So here's the thing. -3 and -2 means the arguments that are second to last and third to last.
Yeah.
Right? So first of all, we are assuming that that argc is at least 3.
Mm-hmm.
Right? Otherwise, if not, there is no third to last argument.
C contains the
argc is the number of arguments.
well, but it contains the program name, right?
No, not here.
Okay.
I subtracted it.
Oh.
Right, so that's the first thing. We must have at least 3 arguments.
Right.
So it has to be of argc -3.
Right.
and args of argc minus 2 and the result. So actually these are not, well, no, I can actually use the argv. And then I can assert that actually this is correct. Plus args equals result.
And argv, did you advance those?
Huh?
Did you subtract from argv?
I did all of that.
Oh, yeah.
It's taken care
I
of.
was like, why are you doing okay.
Okay. Is this going to work?
I'm confident.
Was that?
Dang it.
Well, that always happens. What? This is args. That's easy. Oh, well. And then I also forgot that. Others don't count. Reaches 0, sure, whatever. Okay. Simplying 1, 2, 3. Okay. Why is that?
You didn't call it.
Oh.
You need to say which function, right? Yeah. Okay.
Yeah, because we're not reading a file in this case. Yeah. We don't have a. Excuse me?
Sounds common.
Okay, that's interesting. Oh, do you want to try out the GUI?
Yeah.
So I just read this recently. You can type GUI. Holy shit! Select next view tab. Page help. Select previous. Select next. Left is unexpand. Oh, okay. Sources. Okay, how do I do anything? How do I run? But I don't even have a source. But that was short-lived. Okay, target, create, process, attached, continue, halt, kill, thread, view. View? Oh, what the hell? This is completely useless. Okay. What? Oh. Oh, wait. Does scan init Oh, that initializes the pool. That okay, that's stupid. See, the pool should be self-initializing. Why is the pool not self-initializing? So what does the pool have? It has the active chunk, it has the fill pointer, and it has the chunks. But the problem is that when you're allocating and the active chunk is 0, then well, I mean, first of all, the context is on the stack, so I can't expect it to be initialized in any way, shape, or form anyway. Okay. Pool init And then the scan main will not do that. Is not a, yes, that is correct. All right, let's try this again. All right, 1 + 2 = 3. That looks good. Oh. Great, so that was assignment 2.2. So the next one is going to be the most difficult one because we have to parse the VM code. Assignment 2.2. So let's look at the assignments again. So we have to write a parser for the files. So the files have 1 line per VM instruction. You can't have empty lines or anything. You can't have comments. There's a line number, but the line number is just there for commentary. It has to start at 0 and always increment by 1, so we can ignore it. Then there's white space, and then there is the name of the instruction. Then there's white space, and then we have the arguments. So let's go to vm.c. And now the first thing is that we need to figure out how we're going to store the instructions. VM instruction T. So we can just use an enum for the instruction type. Enum def enum VM instruction VM opcode. Let's call it opcode. And the ones that we kind of have to implement them all. Do we have an easy access list of all of them? Not really. Okay, let's just do this. VM op. So we have move, we have set, we have add, we have multiply, negate, not, jump if 0, all return less than equals. Oh, that's it. It was easy. So this is the opcode. So then there are at most 3 register operands, and I think we can limit ourselves to 32-bit integers with the slots. I'm sorry. That's like 4 billion slots that you can address relatively. We're not going to use anywhere even close to that. So
for those arguments, you don't use the 32-bit.
come again?
So for those arguments where you don't use the for the not for the slots, but for the set method, for example.
Oh well, so here's one thing we could use. We can have we have one instruction that actually needs a 64-bit number, which is set, right?
Mm-hmm.
However, set uses one slot. So we can either have one slot and a 64-bit number, or two or three slots, or actually 0 slots, or an instruction, but we're going to use 32-bit for that too. So what we can do is, yeah, it takes an instruction index. We're not going to have more than.
Or call, sorry.
Yeah, same thing.
But there's a number.
Oh yeah, but that's an offset to the value stack pointer.
Oh, okay.
So it's kind of like a slot. So what we can do is we can store one slot, or let's call it arg1, right? And then we can use a union to store either 2 more slots or 2 more 32-bit arguments, or one 64-bit argument.
Oh, okay.
So we get a bit of a more compact representation of instructions. And I'm going to call it A. And it's going to be T.
Put the R1 in there and then just, then.
That's not how unions work.
No, but then, I mean, you'll have 2 R1s in the union, but like the addressing the first slot is not going to be that much different than.
Oh, I see what you're saying. Well, okay, fair enough. So basically what Pate is saying, instead of having the arg1 outside, is have 2 arg1s inside the union, right?
Mm-hmm.
So here we have the, let's call it args, and then let's call it struct. And this is, we're going to call this this is im. We have arg and im. We're going to call this the immediate instruction format, and this is the, I don't know, the slot instruction format. I'm just making shit up. So then we have arg1 and arg2 and arg3. Okay?
Okay.
That means, of course, that we need to do special handling in the parser, but that's fine. It's not that complicated. Like, really, only one instruction needs special casing. Okay. But that also means that in the VM, we need to have an array of VM inst that I'm going to call code. I'm going to call it instructions. Let's just call it instructions. And let's have a, we're using int32s, let's have num instructions. And how are we going to do that? We unfortunately don't have the nice, we can only use the dynamic array for pointer arrays. So yeah, we're going to have to write our own stuff. Or do we? Should I use the trick from before?
We're doing what?
No, I'm going to use a trick. I'm going to dynamically allocate the instructions first, one each, and I'm going to use a dynamic array to store the pointers to them. And then when I'm done with all the instructions, I'm going to flatten it out into one big array. Okay, so that's all stuff you don't have to worry about if you program in a higher level language. So let's call it, actually, let's call it void VM load. And yeah, I guess it will take a VM and you give it a file name. So the hard part. So what we're going to do is, well, first we need to open a file. Open file name R. Then we're going to use fgets. Is it fgets? Yes. So fgets takes a. By the way, this is kind of cute. This shows you how naive people were in the old days when security was not an issue. This reads one line into a buffer, and you can't even specify how big the buffer is. You just have to make sure that the buffer is big enough. If the line is too long, it just overwrites the end of the buffer. And
just write over
you can just write over everything. So basically, if you use gets, your program is completely exploitable. So we're not going to use gets. Our program is still completely exploitable for other reasons. Anyway, we're going to use of course, we're going to use a piecewise buffer. Define.
restrict?
That's like new C# pointer stuff. Don't ask me.
C#.
There's C#, C pointer stuff. Don't actually know what restrict does. Char fine line length. So we're going to read into the line the size of the buffer is line length, and the stream is f. And what do we get in return? The new line, if any, is retained. If any characters are read, a 0 is appended to the end of the string. Okay. I'm going to point to the string, and the file occurs before any characters are read, they return null. Okay. So if fgets equals null, okay, let's just say while fgets is not null. And we have a line. Does the VM have a context? No, the VM does not have a context. So we're gonna. Actually, we don't need the only thing we need is the pool, right? We can make our own pool here. And the dynamic array also only. What am I doing? Our dynamic array also only takes a pool. Yeah, okay, so we can have a dynamic array. So we're going to make a dynamic array to store the pointers to the instructions. from the pool. Now we need to read one instruction. And we allocate the instruction dynamically. VM instruction t ins equals pool alloc. From the pool, we allocate a size of VM instruction t. And then we're going to define our append to the instruction pointers, the instruction, and at the end here, we're going to flatten out the whole thing and put it into the VM. Does that make sense?
So when you say flatten, what do you mean? Because it's just like an array of instructions.
Yes, but right now we have an array of pointers to instructions.
Okay.
So I need to allocate one big array
and
then copy over the individual instructions. So now I need to actually read the thing. We kind of do have code in the scanner. I wonder if I can use that. But I'm also kind of lazy.
It's not really.
So I'm going to do the following. I'm going to do I'm going to write a skip function that takes a pointer and I can tell it which characters to skip. Okay. I'm going to skip digits and white space, which will put me at the beginning of the name of the instruction.
Are you not going to make any assertions about like the program instructions being in some kind of order?
No, I mentioned previously that they have to be correctly. Like we can ignore the line numbers; they're just for convenience's sake when you look at the program, and you want to see which line does this instruction jump to. Oh, it jumps to instruction 15. There's 15 over there. So this is skip. Does it take a const char? No, it cannot take a const char. This is a const char p. That's just set. Set. So while there's this function called searcher, which will search in a string for a character. So actually, what I'm going to do is while searcher searching in the set for the character that I'm looking at, I'm going to assert that actually I'm not looking at the end of the string, because that would be bad. And I'm going to increment by one character. So as long as I'm looking at a character in the set, I'm incrementing, and then I return the new pointer. Does this make sense?
Not equal to 0.
So strings in C are null terminated.
Yeah. Oh, okay. Yeah.
Do we have to return the character?
He is not the
Because we
character.
already passed the pointer.
Well, I mean,
okay.
If we don't, then you're just wasting CPU cycles and you're not producing any value. Like, why are you?
I thought because we had the pointer as an argument passed to the function.
Yes, but all I'm doing here is modifying the pointer.
Okay, yeah, right.
But the pointer is passed as a value, right? Yeah, I can modify p here as long as I want. This is not going to change, right? It's not going to change long.
Okay, right. Yeah. Oops, my bad.
Pointers are values. But I can pass them. I can pass pointers to them, but I didn't in this case. Okay, so I've skipped over that. Now I'm reading. Okay. Now I'm going to make another one. I mean, I could skip over all the letters, but I don't want to do that. So I'm going to make another one that looks almost like this one. But I'm going to call it, no.
You need to get the opcode.
Yeah, I need, okay, how do I get the opcode?
I mean, you have to, like, while you have characters and you're not like at a space, you need to like take that thing. Well, you need to basically parse that word, and then now you have to that.
So we already have the we already have set the pointer to the beginning of the instruction, and then we just have to get to the first white space after that to get the word length of the instruction, and then just
how do we get to the first white space?
We make another loop, I guess, and
like a loop like this one.
Kinda, or we just have to. Looks exactly like that. And we just check a white space. Yeah, right. Okay.
Right. So now this is the start. I should call it start. This is the start of the name, and this is the end of the name. Right now I have the name.
Can we just set the end of the name to 0 then? To set the end of the string, or would that be cheating?
No, I can do that, but I don't have to.
Okay.
What I do need.
Why is it equal to null this time?
Well, because this time I'm finding a character in the set. So while as long as I'm looking at a character that's not in the set, I'm incrementing, right? So I'm going to actually make a VM opcode t function that I'm going to call which opcode, and it's going to take a length and whatever, name and length, right? And length is just the length of the
string.
The length of the string, so I can use stringcomp. Can I use stringcomp? Yes. So here's what I'm going to do. I'm going to make a, this can be static. I'm going to make an array of names. And here are all the instructions. Of course, these are not names, so I have to do a little, what is that? Is it that? Okay. That's a little annoying. Should have done that before. Jump with 0. all return less than equals. So these are my instructions. And then I have null. And these are in the exact order. These must be in the exact order as note, keep in sync with which opcode in vm.c. Now all I need to do is for int I equals 0, as long as names of I is not null. If strillen of names of I is not the length, continue. If strincump, I don't know which, yeah, the size is at the end. Okay. If strincump name, comma, names of I, comma, len equals 0, return vm opcode t I. Otherwise, assert false. Does this function make sense?
Yeah.
There is a reason why I have to check for the length independently, because, I mean, not in this case, actually, because the only two where one of them is a prefix to the other is jump and jump if 0, right? But if these were in the opposite order, for example, and you gave me jump, then this strincump would be successful too, right?
Yeah.
So I would return jump if 0. But lucky for us, but I don't want to add another restriction. Like if for some reason you change the order or something, then it doesn't work anymore. You don't want that. It's a little bit more robust, this code. Okay, so now we know what the instruction is. VM opcode t. Well, actually, I can just allocate the instruction. Oh, I have the instruction. Int opcode equals which opcode of end minus start. Okay, that was easy. So now, come the arguments. Do I always have an argument? I always have at least one argument, right?
Yeah.
Yes.
Oh, return? Yeah, return true.
Yes, return also as an argument. Okay. So let's skip white space as well as dollar signs. Right, so we don't want this either, this thing. Just want the 0. We're not interested in the dollar. Yes, correct?
Yeah.
Okay. Char. So we're gonna again say start equals end.
You're declaring.
Oh no, this is start. Yeah, I know. So this is start, and I'm actually gonna, well, end equals skip start, and now I just want to read digits, right?
Mm-hmm.
And this is my first argument. However, it kind of depends on, okay. let's look at this is function, what is it called? Str2D, str2L, or str2LD. Oh, that's nice. I can pass an end pointer. That's exactly what I need. End pointer. If endpoint is not null, oh, stores the address of the first invalid character. That's fine. Invalid. If end pointer converts a string, string may begin with an arbitrary amount of white space. If base is blah, 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 the remainder stopping at the first character, which is not a valid digit. So that means that if I convert end, if I actually ask him str2L, start, convert end, base is 10, then convert end should be the same as end, right? Because it will point to the first character that is not part of the number.
Oh, okay.
According to the documentation. So I should be able to say, assert this. Right?
Yeah.
And also, this is our first argument. And now, depending on which... Now, I could make a loop, but maybe I don't want to do that.
You have to check whether the next one is like
yes, also, and yeah.
at the end 0, or because it could just be one or one.
Yes, yes. VM.c. Well, it's not that simple. So we have a few cases. Actually, here's what I'm going to do. I'm gonna also return the number of arguments to which opcode, so that I don't have to check whether there's a comma or something. I just, if I know that I have to parse another one, so I'm gonna have a name and args. And it's called instructions, whatever. Is that syntax correct? I don't know.
Is it? It doesn't look right. First of all,
it looks really weird. We'll see soon enough.
plus you're missing the n args. Okay. Cool. No.
Oh. Let's just give it 3 by default, and then we'll fix it up later. No, that's too many. Okay. So move has 2. Set has 2, but set is kind of a special case. Actually, let's just return -1 for set. Add has 3. Yeah, okay. Add, multiply has 3. Negate has 2. Not has 2. Jump has 1. Bit 0 has 2. Call has 3. Return has 1. And less than and equal should have 3 each. Now, of course, we need to instructions of I.name. Name, and in here we say nargs equals instructions of I.nargs. Okay. So we also get out here in nargs. We get the nargs out. We can always use the first argument, right?
Mm-hmm.
How about we just write a function static that parses an argument as a 64-bit integer. And it's going to modify the pointer. So the way we use it is we say arg1 equals in 32t, arg1 equals in 32t parse arg, and we give it the end pointer. And it will modify the end pointer to point to the character right after the argument. That way I can just re-invoke it with the same pointer. So end is P. And what I'm also going to do is I'm going to skip a comma so that I don't have to special case that. Right? So if I'm at the end of an argument, I'm going to skip over a comma, I'm going to skip over white space, I'm going to skip over $. So I have to be at the beginning of the next argument.
Mm-hmm.
Agreed?
Yeah.
Let's do this here. Convert end. I convert it, except that now I need to use str to LL. And then I can say P equals end. Return arg. Boom. Now I got my first argument. But now I need to special case if the nargs is -1, then I have the set case, right? Otherwise, I can just go in 32t arg2 arg3 if nargs is at least 2, I need to read another one. arg2 equals arg2 equals this thing. And if nargs is at least 3, I can read the third argument. I'm just going to set these to 0 just to make the compiler happy. And then I can just say ins. Actually, I don't even have to say that. Yeah, whatever. Let's do it anyway. Let's be nice. I can say ins args slot arg1 equals arg1, 2 and 3. So that's nice. And here, in 64T, in equals parse arg and what I do is something similar to here, except that now it's not slot, it's im arg, and im is im. So now I have an array of instruction pointers, but what I actually need is an array of instructions. So what I need to do is I need to VM instructions equals malloc size of VM inst times dir length of int pointers for for int I equals 0 as long as I length. Int pointers I++. Mem could be VM instructions of I from. What is the syntax to get something out of it? Dinar nth. Dinar nth int pointers of I size of VM instruction T. And now I can free the pool. Pool free. Pool return VM. No, I don't return the VM. The VM has been initialized for us. But what I do need to do is I need to say VM num instructions equals. Actually, let's and num instructions. Num instructions. All right. Does this look good?
It's dangerous.
Yeah, it looks very dangerous. You're absolutely right.
You actually pound define the line length person.
What? Where?
Line length?
Yeah. I just where did I define here? So where was I? Do I actually do that now? No, I don't. Main.c. So in main.c, I'm going to do VM main arg v of, well, yeah, we're going to throw away what we have here. Arg v of 1 is going to be the name of the VM program, and then these are the arguments, but we're not going to do anything with the arguments yet. I mean, we can push them. There's no reason not to push them. Except that here we get a file name. This I don't need anymore. I'm going to init the VM. Then I'm going to load. And then I'm going to push the arguments. This is all bullshit. I can delete that assignment. Huh. So I would say if it doesn't crash, it's already a win. Do we agree?
Mhm.
Okay. Sure.
Discards qualifiers. Oh. Sure. Passing args, discards qualifiers, where? Oh. Argv, unused function. Yeah, okay, that isn't string.h. Sprinkum. Oh, I also need to include dinar.h. Use of undeclared inspectors. What? Wait, what? Oh, because it didn't know about that, I'm guessing. Use of use of undeclared identifier P. So this must be start. Inspectors, dinar, could be in string. Again. Where? I shouldn't have started this function main, but apart from that, it's looking pretty good. Okay. Let's try that. Oh, yes, of course. So we have in examples, what was it? Next prime dot, no, next prime simple dot SBC. Aha. That's interesting.
Don't you need like an argument?
No.
It's fine. It's simple.
Okay. What is start? Start is it's -2. It should be able to do. Oh, wait. Ah, okay. I forgot about that. So we skipped over digits, but we didn't skip over the minus, right? So end points to the minus, as does start. And then, of course, aren't you glad I added that assertion? Nobody's glad I added the assertion.
Yeah.
Good job.
Doesn't crash. So let's break in VM main. Break. Point B. Next. So now we can look at VM instructions. Does it print in? Is it? Oh, wow. Okay, let's actually look at the code. Examples. Next. Simple. UMP 180. Look at that.
Good.
It looks very good. So let's look at one. This is move. 1, -2. Let's look at set. That's at 3. 463. That looks good. Let's look at 4. That's a 3 argument thing. 3, 2, 3. Up less than. Let's look at maybe a call or something. Call at 35. 184. I mean, what can I say? How many instructions do we have? Did it tell us that? 183, is that correct? Yes, 0 up to 182. So that's 183 instructions. Boom.
Nice.
I did not expect that. Yeah, let's end it here for today. This took more time than I assumed it would. So we did this. We wrote the parser, and in the next one, we're gonna implement at least. We're gonna at least do 2.4 and 2.5. So 2.4 being implementing add and set, and then implement return. But the only thing it needs to do, it doesn't have to care about the call stack. It just has to end the program, because we don't have call yet, so it doesn't make sense to do anything else, right?
Yeah.
It prints whatever's in that slot, and then it ends the program. And then we're adding move and multiply, negate, not, and less than. And maybe if that's super easy and we're done with it in 10 minutes, then we'll do 2.6. And then we can even have loops. All right?
Cool. Sounds good.
Awesome. Then I'll talk to you guys next week.
Thank you very much.
Bye.